Hi, it's Greg from Curry Country Living. In this episode, you're going to see 3 different stoves that I have personally owned and used, how I went from a conventional to a gasification and then back to a conventional. The conventional you see in the background is the newest stove that I just put in the fall of 2022. I had a Polar G2plus gasification unit in the winter of 21-22, and we're going to talk about some of the reasons why I changed from conventional to gasification and then from gasification back to conventional. So in 1990, I picked up a Aquatherm outside wood boiler, wood stove for the farm here. At that time, I have the house that was built in 1911. I have a barn, a hog barn that I was raising hogs in. The hog barn burnt down in 91. Long story short, that Aquatherm heated the house by itself until about 2020 when I started doing some welding and some repairs, and it was starting to look into a new unit. So this stove has been in the same location since 1990. I had the River Rat hockey team help me unload it from my half-ton. I picked it up in Brandon. It came from Sullivan Lake. I believe it's an Aquatherm. Basically, it's 2 drums welded together and has been faithful for the last 30-some years, 31 years. And yeah, we took it out. I pick up my new G2plus Polar stove tomorrow, and hopefully it will go as nicely going in as this one came out, but she's been a faithful old stove unit. Looking around, gasification, there's a lot of hype on gasification. They're a very efficient stove. In the United States, there's a huge tax break, up to 30%, I believe. We don't get that kind of a break here in Canada, but they do use a lot less stove, and I shouldn't say a lot less. They use a measurable amount of less stove, so they're very efficient. I think anywhere between 80–85% efficiency. With the conventionals, they're not quite as efficient, but they do have some benefits. So when I picked up my Polar G2plus, I knew I was undersizing. That was probably a mistake looking back now. I have about, the house has got about 3,100 square feet, and the barn, depending on what I'm heating, because I heat different parts of it, we have an upstairs loft to it that's 80 by 30, so 2,400 square feet, and the same on the bottom. But at any one time all winter, I want to heat approximately 4,000 to 5,000 square feet. And there's a mistake right there. When you start talking about square footage, this house that I have behind me here, built in 1911, an addition built on, windows replaced in probably 1995, is that 4,000 square feet, 3,100 square feet, the same square feet as a house that was built in the last 10 or 15 years. No, it's not. So be careful when you're talking about a stove being able to do a certain amount of square footage. Take a look at what you're heating with it now. In my case, I'm using 220 kilowatt 220 kilowatt electric boilers, one in the house, one in the barn. And when it gets down to minus 30 or 35, it's all that those boilers can do to keep up with the heat requirements. So if you're sizing a stove, maybe consider what you're heating with now, and maybe do some calculation factors and seeing what you need. So basically, the G2 Polar gasification unit is rated for 4,000 square feet. Instead of talking about that 4,000 square feet, it's probably putting out 110,000 BTU, give or take, an hour. So it's better off to probably look at the BTUs. So last year, the conventional, I made some mistakes. Number one, I undersized it. The stove was way too small for the heat requirements that I needed. I miscalculated on the learning curve. There is a learning curve on these stoves. Don't think you're going to just pick one of these things up and treat it like a conventional and get away with it. One of the big disadvantages for me, if me and my wife want to go away for vacation for 2 weeks, I've got to have somebody that knows how to work that gasification stove. It's not like a conventional, not quite as forgiving. The third thing is, so even if I do reduce, and I did reduce the amount of wood, hard to tell on a cold winter, but it's obvious that they are more efficient, is it the wood needs to be good moisture, like dry, well seasoned, and it should be split. So if you're talking 15-20 cord of wood, that's a lot of splitting. Like that's a shitload of splitting. So that was another thing I didn't really factor in. I kind of thought, oh yeah, lots of son-in-laws and and we've got lots of time. So depending on what your heat requirements are and how much wood and how much time you're willing to put in, that's something to consider. With the conventional stoves, cut them to the length of your firebox. Don't need to split them. Throw them in. Moisture isn't near as much of a factor. So going back to the conventional, I've got this 3444 Polar Portage Main behind me, and I'm absolutely loving this stove this year. I picked it up in late September. I think I had it up and running in October. I can put any length of wood I want that fits in the firebox in there. Moisture isn't a problem. I've still got quite a few of these totes from last year that I split thinking that I would be using with the G2 Polar. But what I'm finding with this stove behind me is that I'm getting anywhere from 12 to 15 hour burns without stoking it too heavy in what I would call normal, more normal weather than we got with the G2plus last year. Last year, I keep referring to it as a winter as hell, but if you look on Google, you'll see that it's probably one of the coldest records, or within the top 3 coldest records that we've had since we've been recording temperatures. And so in this video that you're about to see behind me is me going up talking to Travis, and we talk about a lot of different stoves up there. Basically Heatmaster and Portage Main are the two big ones in Manitoba. We don't have a lot of the stoves that are available down in the States, but the neat thing about going up to Travis is he has some of those other stoves on site. You can take a look at them. So welcome to Curry Country Living. I got Trav with me today, and we're going to talk about different types of stoves today. We're going to talk about the gasifications and the conventional, and I'm going to talk a little bit while we're going along about what I liked about the Polar, what I really liked about the Polar, and some of the drawbacks that I had, Trav, and maybe you can address some of those. But behind me we have some of the conventional wood stoves that Polar and Main make, and maybe we can go through that first, and then I'll talk about some of the things I liked about the Polar and some of the things that I maybe be looking at a conventional for.
Okay, so we want to start by looking at this. So right off the bat, you have your storm door. So it'll help your heat retention. You have two keys, so you can lock your doors. So if you have younger kids playing around, or you're just worried about anything happening when you're gone, by having this door shut, you have nothing to worry about. So now this storm door opens. It has a fiber board insulation underneath, so styrofoam with the reflection. Then, so right here you have your 2-stage latch. So right there you open. So this will prevent, if there is a blowback, the door is not going to come at you. So that would only happen if the stove was running hard, it just stopped, and then you decide to refill your stove right after it turned off. Well, all that smoke, it's rich in fuel, so it's just sitting there waiting for oxygen to ignite. So it's always good to have your, either time your loads or load it when, like, have it running, then turn off your fan and then throw your wood in.
So something that's different from the gasification, like by opening this door, no fan kicks in or out. It's basically sensing the water temperature.
Yeah.
So if your temperature's up to temp and you open that door, there could be do it slowly. And that's what that emergency double lock is for.
Exactly.
Yeah. So right now we've got the door open. This, what size of stove are we looking at in this particular one?
So this one right here is the 3444. So that'll stand for 34-inch width by 44-inch length.
So basically it's 34 inches of width from side to side, And you can put up to a 44 or 42 inch log. 44 is probably the max, I'm guessing, but
yeah, it's nice throwing 3-footers. They're easier to handle, and
yeah.
So then at the bottom you have the shaker grates. So Portage Main, they were the original shaker grate. They made the first time tested shaker grate. Yeah. So here's your shaker grates. The handle moves up and down, which pivots the
so that just shakes the ashes down into I'm assuming this bottom drawer here.
So this will be your ash cleanout. So right there you got your large ash pan, and most of the time you maybe only touch this once a week. And then the end is cut off, so then any ash that does fall down that didn't end up in your pan, just by pushing it like so, it pushes ash right into it.
So looking at the firebox here, Trav, it's brick lined, and I guess that's where the BL comes from. But can you tell me about the bricks?
So the brick line, these are all casted brick, customized for the Ultimizer. So by having the brick line and the dry bottom and the 2-piece sectional, we have the only fully rebuildable boiler that you can split the heat exchanger and the firebox and have all brand new interior insides. And so at the top of this brick, that's where the fire jacket or water jacket starts. So
there's no water below that level.
Correct. Yeah. And so by having a dry bottom, you get a hotter, intense flame. Any moisture that drips down is like anytime your boiler idles, you'll get creosote, you'll have moisture dripping down the wall, and when that moisture gets down to the base of the fire, it can actually burn it off. But now if your whole entire base is cooled by water, it never fully dries. So by having, and then on top of that, by having a hotter base at your fire, you're able to burn more complete, while also we have secondary air inlet coming through the front face of the fire. Yeah, right here.
Go ahead. Yeah.
So this is your secondary air intake. So the air is being pulled through the base of the fire, which would be underneath the shaker. So it's preheating the air for one, while also air coming from beneath the shakers as well. So by having air coming from underneath the shakers, you're going through that coal bed, but you're off-gassing at a very intense rate. And so you need secondary air, or else you have a very rich fuel environment and you don't have any oxygen to burn off the remaining fuel. So it'll go out as smoke. These boilers will clean up within a couple minutes of firing. They're designed to burn hot in the firebox and then collect all the heat in the heat exchanger and the top portion of the firebox. So the base is the engine of the fire.
So the heat exchanger, I know. So I'm looking inside here, and at the very back is where the smoke is, where the smoke and some heat are going out.
Correct. So
what happens then?
So that's a water-cooled fin before it goes to the rear portion of the boiler that enters the multi-pass full front-to-back heat exchanger. So the air's coming through the grates, coming through the front. It's hitting that fin, creating turbulence. So it's actually creating a mixing effect, its own little fireball within the boiler itself. So it's getting the mixing, it gets the heat, and it has the oxygen. So all the three three elements that you need for a good combustion are all there in this firebox. So now we'll move to the top chamber. So to latch, single hand latch, nothing special. That's how simple it is. So now the top chamber here. So right from new, you'll have your clean out tool. So you'd scrape this every week, push all your, you want to push your ash, any flake creosote to the far end back to the boiler, and you'd want to pull everything from this end to the front. So because this is where the smoke, like all your stack is, this is where all of your exhaust is coming from the firebox, is from the left side. So by pulling everything to the front, pushing it to the rear, everything will end up right back into the firebox and burn up.
So just going by that one more time, so on this side you want to pull it because it's going up out the chimney there. So you're going to pull it to that side, and then you're going to push it to the left side, and that'll put it back into the firebox.
Correct. So now there is a clean out tee at the back. So what I mean by full front to back, 360-degree water cooled heat exchangers. The very rear of the boiler, where the exhaust comes, it's coming all the way from the very far back all the way to the front. Then it's doing a 180-degree turn to the rear of the boiler, and we do not have a stack going through the roof, which having a stack going through the roof could, and if your silicone ends up deteriorating, now you're saturating your insulation with moisture, which degrades your R value, ends up making a mess. So by having the tee, you're avoiding any leaks and water ending up in your insulation, and you're getting that extra heat exchange surface.
Because your chimney's not inside taking space.
Correct. Because they would have to stop this heat exchanger early, partway through the run, if it was going through the roof. So far as I know, with the multi-pass heat exchangers, we're right on top of having the most efficient, being that we have even the center where the heat exchangers are side by side, that's water cooled in between. So we have heat exchange on the bottom, left, top, and center.
So there's water in that divider?
Correct, yeah. So full front to back with 360-degree water cooling gives us the most efficient multi-pass.
What kind of metal? What do we have? Is it mild steel in this?
Yeah, so there's two options. You can either get 409 stainless steel, or you can get 1/4-inch boilerplate steel.
This particular one is boilerplate?
Yeah. Okay. Yeah, being that this boiler, like they last anywhere from, so they have a 20-year warranty, but you're going to find that lifetime varies, all depending on the amount of maintenance you do. If you're running it during the summer, if you're doing 12-hour loads instead of 24-hour loads, there's a lot of variables. But the neat part about this boiler is that it's fully rebuildable. It's the only boiler on the market that you can, it's a two-piece sectional. It splits apart. You can have a brand new boiler, insert like the internals for 1/4 the cost of the brand new unit. So while other boilers are throwaway, this is fully rebuildable. No boiler that ever goes through the factory, you'll never see one of these thrown out. So
okay, and I'm just gonna, is Portage Main the only ones that do that? Is that
well, when it comes to that, Heatmore has a dry bottom, but they aren't a two-piece sectional from what I've heard. But
okay,
I guess the other point that I'd like to make is by having the fire brick and by having that intense amount of heat, the dry bottom, we're able to slow the combustion down. So we don't need to pound our boiler full of air to get to clean up our smoke. Like we don't need to pound air to get a hot fire. While other boilers without the fire brick, they need to have their fan going full tilt, pounding their boiler full of air just to initiate the amount of heat to get a proper combustion. So by slowing down your air movement, you're able to extract more heat in your heat exchanger and in your water jacket. But yeah, back to that other topic, yeah, when it comes to all the main manufacturers, this is the only two-piece. It is the only rebuildable boiler. Like the Heatmaster, Crown Royal, all the other big guys, they're a throwaway boiler.
So when did Portage Main go to the two-piece? Has this been one of the designs? So
this has been a part of the design for a long time. Prior to this, they had their ML, they've all been a dry bottom. Even the new chip burners that are out, the LCB, they're a dry bottom. And they all, well, the LCB utilizes fire brick, the new chip burner series. There's a reason why all the wood stoves have fire brick in them. Why should it be any different for a wood boiler?
Can we take a look at the back and you can show me what's going on back there?
Yep. It comes with a 3-foot section. You don't put a cap on it, you leave the cap off.
What's the reason behind that?
So by putting a cap on there, like it doesn't come with one, but by putting a cap, when you're idling, your cap's going to be cooler, and which would allow creosote to develop on the cap and actually restrict your flow. So which could actually end up turning into say a chimney fire. Like there's a few guys that put caps on these, but then they're throwing cardboard in the top chamber to clean out their chimney every once in a while. But by leaving it straight, you put a bucket over it at the end of the year, or use a clover, the clover style chimney. So on this boiler, there's no solenoids to fail. It's a simple primary aquastat. This will be your fan switch, on off, and you have your damper within this chamber right here. So there's solenoids, they can fail at any time. Even actuators, just another moving part that isn't necessary.
So what happens, so there's a damper inside the metal part here.
Yeah.
And when the fan kicks in, I'm assuming that the damper does this?
Yeah, correct. So by having it like that, in the idle phase, it doesn't let a whole lot of air enter, so it'll prevent overfiring and natural draft.
Yeah. So how many gallons of water in this unit in the 34?
So they got 120 gallons in the 3444. You got 90 gallons in the 2840, and then you got 60 gallons in the 2534. And we do have a larger model up, which would be the BL40.
And as far as BTUs, I know I'm going to be talking to you about that later, but as far as BTUs, this unit will put out...
It'll put out approximately 370,000 BTU.
Per hour?
Yeah. So that'd be if you're, like, obviously at that large amount of heat, you would have to load your boiler more often than 12 hours. But that would give you an estimate of the raw BTU output that you can achieve.
The piping looks quite straightforward. You have two outlets, and then your inlets are up, or your return are up there. And something neat about that you showed me a little earlier was they're a little bit movable.
Yeah, so they're on a swivel, and so you are able to, when you put your attachments on there, your fittings, it would get quite tight with your wrench, so you can pull these out. so you can actually pull them out and even move them left to right.
Oh, so you can angle the hose however. Yeah.
Yeah.
And then the chimney, we were talking about the chimney on the other side, but you have an easy cleanup just pulling the cap off. And that's what you were talking about travel. Like the chimney is outside the stove, it's not inside. So it comes out giving you that extra.
That's right.
That extra area.
So yeah, then on top of that, you got your primary and secondary aquastat. So this is, if this ever failed and it was overheating, this would override and shut everything down. But the neat part is, if your primary fails, or say, like most of the time it fails when it's off, so, but if you, and say you don't have one on the shelf, you can wire your secondary, which we have instructions on our website on how to use your secondary as your primary until you can get a new one.
So if your electronic one or your digital, and electronics have been known to fail, if it gives up the ghost, you can use your secondary to run the stove.
And doesn't happen very often. Just like anything mechanical, it can fail. Anything electronic, it can fail. So just gives you peace of mind. And
then the motor itself, like that blows the air. It's definitely not as big as the G2 Polar.
Yeah, when it comes to the positive pressure, you don't need that big of a fan. So this fan does more than it needs. It does everything.
Just off topic, but does that slide back and forth?
Yep, that slides back and forth.
Well, thanks for watching. If you enjoyed that video, consider giving me a thumbs up, subscribing to the Curry Country YouTube channel, or my favorite, leave some comments in the comment section below. Maybe you had some questions about some of the stuff that you've seen. Maybe you agree or disagree. Maybe you have some experience with the gasification and the conventional yourself. The whole gasification conventional, one thing I didn't maybe say at the front is that they are very, very efficient in the fact that they burn up their smoke. So if you're in a close quarter area with neighbors, which I'm not, they're not going to smell the smoke when that wood stove fire is up. As always, stay safe, and we'll catch you next time.